What's going on? My name is Tosh Dalday. This is SDG Labs. Welcome to class Physics! First of all, notice that this is a triple dot problem, which kind of means it's going to be one of the hardest ones. Let's try it. A basketball is thrown horizontally with initial speed of 4.20 meters per second. A straight line is drawn from the release point and makes an angle of 30 degrees with the horizontal. What is the release height? Alright, so we got a dude.
Can, first I just tell you what, I did, and then you tell me, if anything is wrong there, immediately in terms of my process?
Sure. To be honest with you, I don't know the right answer. I don't know how to go about doing this correctly, so I'm just taking a stab at it. But yeah, what's up?
So I used the forward velocity I gave and the angle to find the velocity on the hypotenuse there and the final y velocity.
The velocity on the hypotenuse, what are you talking about?
The line, the dotted line.
There?
Yeah, because that 4.2, it would go on the bottom line, right? If you made that a triangle.
No. The 4.2, it says you're throwing it horizontally. So he doesn't throw it down. He throws it horizontally, and it kind of goes like this.
Yeah, I know.
Okay.
Yeah, but it's 4.2 in the x direction. So
yeah, that's
the
true.
4.2 go along the x, and
that's v
you
naught
would
x.
find what?
This is the v naught x. This is the v naught in the x direction is 4.2.
Yeah.
I agree.
And then if you make a triangle with the 4.2 and the angle it gives you, you can find the velocity in the other direction, right?
Which velocity?
You can find the average velocity along that line.
Oh. Okay, all right. What you're saying is you throw this ball straight horizontally and it goes in a parabolic path, right?
Yeah.
And then you figure out some time that it takes. Is that what you're saying? And then what you do is, based off of that, you can say, well, what if I shined a laser that doesn't deviate? It's a straight path, and it goes at an angle of 30 degrees. Let's say it's a really slow laser, like a really, really slow laser, where it's not even a laser, it's just a particle that somehow isn't affected by gravity. Is that what you're kind of getting at?
No.
Can I kind of tell you my thoughts on this one?
Yeah.
All right, and I don't have this solved out previously in my head. I'll have to take a stab at this, but here's what I'm thinking. This thing right here describes nicely a parabola, right? This curve right here.
Yeah.
This curve describes a straight line. And we know pretty much everything about that straight line because we're given the slope. In fact, I was just teaching Algebra 1 students and I was teaching them about slope equals rise over run. If you know the slope, you pretty much know everything about it. So really what this question is asking is, when does this line and that parabola intersect? Or solve for when they equal each other? That's really what you're asking to do. I think that we can do it. I'm going to take that as h, and h is what we're looking for, right? I'm going to take this at r, and that would be the distance that this thing travels at. We cool with that?
Sure.
I can tell you the relationship between h and r. I can tell you that the tangent of 30 is equal to h over r. And just because my brain is farting, what is the tangent of 30 again? It's isn't it?
0.577.
Okay, 0.57. All right. Wait, I used to know it. I don't know why I can't think of it in terms of roots or whatever. 1030. I don't like dealing with degrees. What was it again? Hold on, let me look it up. Tangent of 30 degrees is 1 over root 3. Yeah, that's right. Of course, duh. Duh. 1 over root 3. Okay? Are we cool with that?
Okay.
Alright. So, let me figure out the y value as a function of time. So the y value of this is simply that same old delta y is equal to v naught t plus 1/2 at squared. I'm going to make sure I get a good coordinate system on this. So I have a positive x, positive y direction over here. Starts off at 0. Can you still hear me and see me?
Yeah, I can.
Alright, okay. Because my computer screen went blank, which doesn't necessarily mean that you can't hear me and see me. Alright, the velocity in the y direction is 0. So we don't have to worry about that. Your delta y is h minus 0, final minus 0. So it's h equals actually, you know what? I'm going to call the positive y direction to go. Yeah, let's do that. So it's actually, your final y is actually 0, and your initial y is h, so it's negative h minus 1/2 gt squared. Those guys cancel, and I end up getting h is equal to 1/2 gt squared. You can solve for t, but that's not really what I want. Let's figure out the range for this thing. Well, I guess you would want to solve for t, but here's what I'm saying is your delta x is equal to v naught t plus 1/2 at squared, but there's no a to deal with here. So we have our velocity initial, which is 4.2 times the time. You can solve for t over here, and you get t is equal to r over v naught. I changed that delta x to an r, it's the same thing. We cool?
Okay.
I don't know if you can see that. I'm just going to write that over here. T is equal to r over v naught. Okay. So I can simply take this and I plug it into here. So that would be h is equal to 1/2 g r squared over v naught squared. All right?
Mm-hmm.
Okay, now, I know this h, okay, this is one equation. This is another equation. Are you good with that so far, so I can erase, give myself some room here?
Okay.
All right, here we go.
But like that's literally what I had on my paper.
Awesome, awesome, good. Good. If this is literally what you have in your paper, I'll be honest with you, this is not easy stuff. Okay. I'm going to solve this thing for r, because essentially if I equate these two, if I say that this r is the same as that r, which you can totally see, because it's saying where do these things intersect? Well, when that r and that r, when this r and this r is the same, and when that h and that h is the same, all we got to do is substitute it in and solve for r, solve for h. So I'm going to make this r is equal to root 3 times h. We cool with that?
Mm-hmm.
All right. I'm going to plug r into here. So I have h equals 1/2 g of 3 times h squared over v naught squared. I just substituted that r in there.
Yeah.
All right. One of these cancels out with that. You're left with 1 over there. I'm going to multiply by 2. I'm going to divide by 3. I'm going to divide by g. I'm going to multiply by v naught squared. I just did a whole bunch of algebra, but it seems that you're really fast with your algebra. So you wouldn't be freaked out if I wrote down 2g, or I'm not even good at algebra apparently. H is equal to 2 v naught squared over 3g.
Mm-hmm.
Is that what you got? You said you wrote that down on your paper. I mean, that's...
Yeah. I wrote that down, but then I got frustrated.
Why did you get frustrated?
I don't know.
I mean, to be honest with you, I think you're done.
I don't know. I did this yesterday. I forget my thought process yesterday, but I have that written on my paper, and then there's something else.
Oh, see, they use a bunch of numbers, but... let's see. You know, they used a bunch of numbers to begin with, so I actually don't like what they did, but whatever. Let's see what we got. So it's 2 times 4.2 squared divided by 3 times 9.8. Can you do that on your calculator for me?
Yeah. Wait, why isn't it negative 9.8?
Because I accounted for that negative already.
Okay.
When I did my delta y is equal to v naught t plus 1/2 at squared. At squared. I made this negative h, and this was 0, and I made this negative 1/2 g t squared.
Okay, it's 1 thing.
What'd you get?
It says 1.2.
That's what your calculator said?
Yeah.
Oh, yeah, that's the right answer.
Okay, and I have that answer written on my paper too, but for some reason I was putting in 0.3 as the answer, and I don't know why.
So wait, you are now getting upset at me because, no, I'm not saying you're upset, I'm just saying you're getting frustrated because you wrote down the right answer, but you didn't copy it over to the computer. Ooh, I can see how you get frustrated because, I mean, you did all the hard work and you messed up the easy part.
Huh. I have no idea where I got 0.3 now.
Well, I mean, Catherine, you did great, all right? You did amazing. That's good. You know, I don't. This is the upper echelon of high school physics. I feel like the upper class of high school physics could do this. And that's it, you know. It's like we're not talking basic physics here. We're talking about like this is higher class stuff. Shoots, bro. Up out.